Bismillahirrahmanirrahim. Dear students, have a nice day. Hope you will be fine best of your health. This is Dr. Sajid Mahmud Rao, Division of Science and Technology, University of Education, Lahore. In our previous session, we have discussed about isolation, purification, and structure elucidations of the natural products that includes terpenoids and lignans molecules on the basis of phytochemical investigation on the constituents of Salvia centralinifolia and Indigofera heterantha. In that lecture, we have studied the spectral techniques as well as biological activities for those compounds, which includes butyrylcholinesterase inhibitory activities for the terpenoids molecules and lipoxygenase inhibitory activities for the lignan molecules. Today, we are talking about the structural elucidations of monoterpene glycosides, which have been derived from the Indigofera heterantha, as well as we will discuss about the proton C13 and other spectral techniques for the elucidations of the monoterpene glycosides molecules. The genus Indigofera that belongs to family Leguminosae, which is also known as family Fabaceae, comprises of 300 species, which are herbs or shrubs distributed throughout the tropical regions of the globe. In Pakistan, it is represented by 24 species. The family Leguminosae is known to be a rich source of flavonoids, and most of phenyl derivatives have been found in this family. The flavonoids exhibit diverse biological activities, and recent interest has been focused on their medicinal and nutritional values. Recently, it was found that a phenyl groups on flavonoids skeleton play an important role in an anti-HIV activity. Indigofera heterantha wall is widely distributed in northern parts of Pakistan and finds various medicinal uses in the indigenous system of medicine. Previously, triterpenes, steroids, and flavonoids have been reported from Indigofera heterantha. In the previous investigation, a methanolic extract of the whole plant of Indigofera heterantha showed positive cytotoxicity in the brine shrimp lethality test. Further, biological screening of both the methanolic extract and its subsequently ethyl acetate fraction revealed significant inhibitory activity against the enzyme lipoxygenase. We isolate different kinds of monoterpene glycosides on the ethyl acetate fractions. Here we report the isolation and structural elucidations of 3,7-dimethyl, 2E6-octadiene, 5-on 1-oxy-beta-D, 6-oxy-acetyl glucopyranoside, and 3,7-dimethyl, 2E6-octadiene, 5-on 1-oxy-beta-D, 6'-oxy-acetyl glucopyranosyl, 1,6-beta-D glucopyranoside. These two compounds will be discussed on the basis of spectral techniques. Let's see the pharmaceutical importance of genus Indigofera heterantha. Indigofera is used as analgesic. Analgesics are medicines that are used to relieve pain. They are also known as painkillers or pain relievers. Technically, the term analgesic refers to a medication that provides relief from pain without putting you to sleep or make you lose consciousness. This genus is also used as anti-inflammatory for insect stings, snake bites, and swelling. Anti-inflammatory is a drug or a substance that reduces inflammation. Inflammation means you have redness, swelling, and pain in a specific part of your body. Anti-inflammatory agents block certain substances in the body that cause inflammation. They are used to treat many different conditions. Some anti-inflammatory agents are being studied in the prevention and treatment of cancer. This genus is also used and play an important role in anti-HIV. HIV stands for Human Immunodeficiency Virus. It is a virus that attacks cells that help the body fight infection, making a person more vulnerable to other infections and infectious and diseases. The phytoconstituents which are present in the genus Indigofera heterantha are alkaloids, monoterpene glycosides, terpenoids, and flavonoids. As you know, the alkaloids are those phytoconstituents which consist of nitrogen atoms in the heterocyclic system, and they are soluble in organic solvents and somehow they are soluble in water. They have different pharmaceuticals as well as enzymatic activities. The monoterpene glycosides are those molecules in which the glucose moiety is linked or joined with the basic skeleton of the terpene molecules. Now, there is a difference between terpenes and terpenoids. In the terpenes, the isoprene unit consists of C5H8, while in the terpenoids, the isoprene unit known as isoprenoid, and it consists of C5H8O. Means there is a difference between only the presence of the hydroxyl group between the basic unit of the terpenes molecules. Flavonoids are those molecules which consist of polyhydroxyl groups in the aromatic ring system, and they are often soluble in organic solvent as well as in aqueous solutions. Phytochemical studies on the whole plant material have resulted in the isolations of two new monoterpene glycosides. In addition, 4 known compounds have also been isolated from this species. These are the known compounds which have been derived from Indigofera heterantha. Let's see the linkage of substituents of these molecules as well as their sources, their pharmaceutical importance and solubility one by one. In the first molecule, you can see over here the name of this molecule is 357 trihydroxy 6,4 dimethoxyflavone. In this molecule, there is a presence of methoxy groups at carbon 3 position in the first phenyl group and carbon 4 positions in the second phenyl group. So you can observe 2 methoxyl groups upon this molecule. Similarly, there is a presence of 2 to 3 hydroxyl groups at carbon 2 position, at carbon 4 positions and carbon 8 position. So the total number of hydroxyl groups that are present upon these molecules are 3. This molecule previously have been derived from the plant Aloysia triphylia. It is used as antiviral and anti-cancer drug. It can be soluble in dimethyl sulfur oxide, methanol, ethanol and acetone. The second molecule is 3,5,4 trihydroxy 6,7 dimethoxyflavone. In this molecule, there is a presence of 2 methoxy group at carbon 2 positions and carbon 3 position, and 3 hydroxyl group are present at carbon 4, carbon 7 and carbon 4 positions upon the 2 phenyl groups respectively. So you can say that this molecule is the derivative of the previous one, but only the difference is here there is a presence of methoxy group at carbon 2 positions, while in the previous there is a presence of hydroxyl group at carbon 2 position. While there is a presence of hydroxyl group at carbon 2 positions of the second phenyl group, while in the previous there is a presence of methoxy group at carbon 4 position in the second phenyl group. This molecule is isolated previously from the plant Sasphium potulectrum, and it is used as antioxidants and might reduce inflammation, that is called swelling. This molecule is soluble in acetone, methanol and chloroform. The next phytoconstituent is 5-hydroxy 3,6,7,4' tetramethoxyflavone. In this molecule, there is a presence of 4 methoxy group at carbon 2 position, carbon 3 position, carbon 7 positions and carbon 4 positions upon the second phenyl group of this molecule. So there is also a presence of 1 hydroxyl group at carbon 4 position. This molecule is isolated previously from the plant Petroselenium crispipum and Apium gravulens. It is used as anti-allergic, anti-inflammatory, antioxidant, antimicrobial, antibacterial, antifungal, and antiviral agents. It is also used as anti-cancer and anti-diarrheal activities. This molecule is soluble in acetone, ethanol, dimethyl sulfur oxide, and chloroform. The last molecule upon this page is 5,4-dihydroxy 3,6,7 trimethoxyflavone. In this molecule, there is a presence of 3 methoxy group upon carbon 2 position, carbon 3 position, and carbon 7 position. You can say this molecule is the derivative of previous one molecule, and there is a difference only upon the hydroxyl group at carbon 4 positions upon the second phenyl group of this molecule. There is also a presence of 2 hydroxyl group at carbon 4 position and carbon 4 positions of the phenyl of the second unit in this molecule. This molecule previously have been derived from the Rutaceae family plants, and it is used as anti-inflammatory and antioxidant. Effects may help protect against neurodegenerative diseases like Alzheimer's and Parkinson's diseases. This molecule is soluble in phenol, ethanol, toluene, dimethyl sulfur oxide, and acetone. These are the new compounds or phytoconstituents which have been derived for the first time from the plant Indigofera hydrantha. The name of these molecules are monoterpene glycosides. As the name implies, this molecule consists of two units. One unit is glycone part and the other unit is aglycone part. So we can say the basic skeleton of these molecules is terpenoids or the terpenes, and the glucose moiety is linked with this molecule as a substituent. So we can say the glycone part is soluble in water and the aglycone part is insoluble in water, and that is soluble in organic solvents. These molecules have been published in Natural Product Research in 2008 and have showed moderate inhibitory activity against the enzyme lipoxygenase. Let's see the extraction and fractionation of Indigofera hydrantha. The whole plant material, that is 25 kg, is grinded and powdered and extracted with methanol and concentrated on rotary evaporator, and we obtain methanolic extract, that is 600 gram. The methanolic extract is partitioned between hexane and water, and we obtain two further fractions, and that are aqueous fraction and hexane soluble fraction. The aqueous fraction is further extracted with chloroform and ethyl acetate respectively, and we obtain chloroform soluble fraction and ethyl acetate soluble fraction. The aqueous fractions at the end is further extracted with high polar solvent, that is N-butanol, and we obtain butanol fractions and the aqueous fraction. In this way, we obtain total 5 fractions on the basis of increasing order of polarity of the organic solvents, and these fractions are hexane soluble fraction, chloroform soluble fractions, ethyl acetate soluble fraction, N-butanol fraction, and the aqueous fraction. The ethyl acetate soluble fraction, that is 95 gram, is further subjected to column chromatography by using organic solvent system, that is an hexane chloroform, chloroform methanol, and methanol. In this way, we obtain total 4 fractions: fraction A, fraction B, fraction C, and fraction D. The fraction A is subjected to column chromatography over silica gel, eluting with 9.7 and 0.3% chloroformethanol. We obtain 3 major spots of TLC, which confirm the presence of 3 compounds, and that are 21, 18, and 19. Compound 21 is confirmed its purity by using 9.9 and 0.1% chloroformethanol, while compound 18 is confirmed either it has been cured or not by using 9.8 and 0.2% chloroformethanol. The compound 19 is confirmed by its purity by using 9.7 and 0.3% chloroformethanol. Fraction B is subjected to column chromatography over silica gel and eluting with 9.4 and 0.6% chloroformethanol. In this way, after final purification, we get the compound number 20. The purity of this compound is confirmed by using thin layer chromatography in the organic purity system, that is 9.8 and 0.2% chlorofluoromethanol. Fraction C is subjected to column chromatography over silica gel and using increasing order of purity of chlorofluoromethanol, that is 9.5 and 0.5%, and after final purification we get the compound number 16. The purity of this compound was confirmed by using organic purity system order, that is chlorofluoromethanol, in the ratio of 9.8 and 0.2%. Fraction D is subjected to column chromatography over silica gel and diluting with 8.5 and 1.5% chlorofluoromethanol, and after final purification we get the compound number 17. The purity of this compound was confirmed by using 8.6 and 1.4% chlorofluoromethanol organic purity system. Now we discuss the physical parameters of compound 16. This molecule is monoterpene glycoside and it was isolated as colorless gummy solid. The weight of this molecule was 21 mg. The specific rotation of this molecule is taken in methanol upon concentration 0.06 and that was minus 19.4. The UV absorption is taken in methanol, which showed absorption at 234 and 191 nanometers respectively. The IR spectrum is taken in potassium bromide, which showed broad CO stretching band in the region of 1128 and 1051 per centimeter, suggesting its glycosidic nature, and at 1680 and 1739 per centimeter, indicating the presence of alpha beta unsaturated carbonyl and an ester group respectively. The HR Fab MS shows molecular ion peak at 373.1868, that is calculated for C18H28O8, and the molecular formula which is suggested for this structure is 373.1862. This is the proton NMR spectral data of compound 16, in which we will discuss about the proton behavior as well as how the structure of this molecule is determined on the basis of this proton NMR spectral data. Let's see the proton behavior upon this molecule. The proton NMR spectrum of this molecule showed signals for a tri-substituted double bond of an alpha beta conjugated ketone at proton 6.12, one proton singlet, that is proton 6. Another signal for tri-substituted double bond at sigma proton 5.50, one proton triplet, J value 7.2 Hz for proton 2. An oxymethylene group at proton value 4.59, that is 2 proton, that shows doublet, and J value 6.4 Hz at proton 1. A methylene group adjacent to the double bond at proton value 3.14 that have 2 proton and show singlet for proton 4, and 3 methyl groups on the double bond at proton 1.84 that have 3 proton and shows broad singlet for proton 8, 2.10 for proton 3 that shows broad singlet for proton 9, and 1.78 proton 3 shows broad singlet for proton 1. The presence of an acylated hexose moiety could be inferred by a proton NMR, that is anomeric proton at proton 4.42, one proton doublet J value 7.5 Hz that shows for proton 1 prime. Acetyl methyl group at proton 1.92 and further oxymethylene signals at proton 3.8 shows doublet of doublet that have J value 12.1, 5.0 Hz for proton 3, and proton 4.56 shows doublet of doublet J value of 12.1, 2.5 Hz. The beta configuration was assigned based on the larger coupling constant of an anomeric protons that have J value 7.5 Hz, and the presence of an acetyl group at carbon 6' was established by the downfield chemical shifts of oxymethylene protons compared to glucose. Acid hydrolysis provided D-glucose, which could be identified through sign of its optical rotation, uh, co-TLC, and comparison of retention time of its TMS ether with that of the standard values. This is the C13 NMR spectral data of compound 16. The C13 NMR spectral data consists of total number of carbon atom 18s, which is confirmed on the basis of broadband and depth, in which there is a presence of 4-methyl, 3-methylene, 6-methine, and 5 quaternary carbons. The signals, which resonate at 74.8, 78.3, 72.0, and 76.2 respectively, indicate and confirm the presence of glucose moiety. Similarly, there is a presence of signals that resonate at 63.3 and 2.8 indicate and confirm the presence of ester moiety, which is linked with the glucose unit. The signals for the anomeric oxygen resonate at 103.8, which confirm the presence of anomeric proton, which is adjacent to the anomeric oxygen atom, and the signals which resonate at 66.1, which confirm the presence of anomeric carbon, which is adjacent to the anomeric oxygen atom. The signals for the methyl group was resonated at 27.7. So the downfield signals at sigma carbon 200.8 and 173.5 were due to alpha beta unsaturated ketones and acetate group respectively. So on the basis of these evidences lead us to assign the structure of this molecule is 3,7-dimethyl 2E6-octadiene 5-on 1-oxy beta D 6-oxyacetyl glucopyranoside. So in the next slide we will discuss the HMDC and no interactions of this molecule, which confirm the stereochemistry and the proton carbon behavior of the monoterpene glycosides, which would definitely be helpful to confirm the structure of this molecule. This is important HMBC correlations and no interactions of compound 16. The HMBC correlations gives information about the proton carbon behavior and correlations, and no interaction gives information about the stereochemistry of these molecules and confirm the position of the hydroxyl group, either it is equatorial or the axial position. So let's see the proton behavior upon this molecule. The proton signal that shows at 4.42 showed 3J correlation with carbon 1, and proton signals that resonate at 4.59 showed 3J correlation with carbon 1 prime and carbon 3. The proton that appears at 5.50 showed 2J correlation with carbon 1, and the proton that appears at 6.12 showed 2J correlations with carbon 5 and carbon 7. The anomeric proton appears at 7.5 Hz J value have an equatorial positions, which confirm the positions of a hydroxyl group that it appears at equatorial and have beta D glucopyranose glucose moiety, which confirm the positions of the hydroxyl group at carbon 1 position. So in this way the structures of monoterpene glycosides is confirmed on the basis of important HMBC correlations as well as no interaction. Let's see the physical parameters of compound 17. This compound was isolated as colorless gummy solid, and the weight of this molecule is 18 mg. The specific rotation is taken in methanol upon concentration 0.09 and that is minus 14.5. The UV absorption is taken in methanol which shows absorption at 205 and 1 and 6. The IR spectrum is taken in potassium bromide disc that shows absorption at 3404 for hydroxyl group, 2926 stretching for carbon hydrogen bonding, 1732 for carbonyl and acetate groups, 1693 conjugated carbonyl groups, 1265 for COC stretching and 11271052 for CO bonding. The HR Fab MS, that is represent high resolution fast atomic bombardment mass spectroscopy, confirm the molecular ion peak at 534.2308, that is calculated for molecular formula is C24H38 and O13, which confirm the molecular mass, that is 534.2312. The proton NMR spectral data of compound 17 is similar to that of compound 16. Let's see the proton splitting pattern of this molecule. The proton spectrum shows signals for a trisubstituted double bond of an alpha beta conjugated ketones at proton 6.04, singlet proton 6, and other signals for trisubstituted double bond at sigma proton 5.58, triplet J value 6.6 Hz for proton 2. Similarly, an oxymethylene group at proton 4.5, 4.42, doublet J value 7.9 Hz, that is for proton 1 prime dash. All structural features were similar to that of compound 16 except the presence of another glucose unit. The proton NMR spectrum of 17 showed two doublets at sigma proton 4.48, doublet J value 7.2 Hz, and sigma proton 4.42, doublet J value 7.9 Hz for two anomeric protons in the alpha orientation, and a 3 proton singlet at proton 1.91 revealed the presence of one acetate group. The C13 NMR spectral data of 17, both broadband and depth, disclosed 24 highly resolved carbon signals comprising 4-methyl, 4-methylene, 11-methine and 5 quaternary carbon atoms. The C13 NMR also confirmed the presence of 2 hexose units, which indicates the presence of signals that resonate at 74.8, 78.3, 72.0, 76.2 and 103.2, that indicates the presence of one hexose unit. The other unit which is confirmed by the signals that resonate at 74.4, 78.1, 79.9, 76.4 and 104.5, that indicates the presence of second glucose unit. The signals for aromatic oxygen appears at 72.0 and 76.4 respectively. Similarly, the anomeric protons appears at 65.6 for carbon 6 prime and 63.4 for carbon 6 2 prime. The signals for methyls that resonates at 23.1 indicates the presence of acetyl group, and 172.3 indicates the presence of carbonyl group at acetyl moiety, which is attached with the second glucose unit. So you can see over here the signals for alpha beta conjugated ketone appears at 200.4 and 122.3 and 155.1. The signals for anomeric protons are the aromatic oxygen atom that is attached to the first glucose unit is 65.9 and 103.2. So this confirmed the presence of two glucose unit and one acetyl unit that is attached with the monoterpene units. So we can say this molecule is the monoterpene glycosides in which two hexose units are attached with the basic monoterpene units. Further, Its structures will be confirmed on the basis of HMBC correlations as well as proton and NOI interaction. Let's see the important HMBC correlations of compound 17, which further confirm the structures of this molecule. Acid hydrolysis provided only D-glucose, which could be identified through sign of its optical rotation. Co-TLC and comparison of retention time of its TMS ether with standard. The downfield shift of carbon 6' indicated that the additional glucose moiety was attached with carbon 6', which was also confirmed by the long-range HMBC correlations of proton 1" with carbon 6'. Similarly, the attachment of acetate moiety at carbon 6" position was also confirmed by the downfield shift of carbon 6", as well as the HMBC interaction of proton 6" with the carbonyl. The proton 1', which have proton values 4.42, showed 3J correlation with carbon 6 1'. The proton 6", which have proton values 4.40 and 4.58, showed 3J correlation with the carbonyl units. So, important HMBC and NOI correlations are shown in these molecules. On the basis of this evidence, the structures of compound 17 could be elucidated to be 3,7-dimethyl, 2E6-octadiene, 5-on-1-oxy, beta-D 6" oxy acetyl glucopyranosyl, 1" to 6,1' beta-D glucopyranoside. This is lipoxygenase inhibitory activity of compounds 16 and 17. Various concentrations of compounds 16 and 17 were tested against enzyme lipoxygenase, which displayed moderate inhibitory activity against this enzyme. The IC50 value of these are given in the below table. In this study, the standard drug that is used as Bacalene, and it shows IC50 value is 22.5 plus minus 0.01, while that of compound 1 shows IC50 value 76.5 and compound 2 shows IC50 value 57.3 respectively. So, on the basis of these values, we conclude that both the compounds 16 and 17 show moderate inhibitory activity against the enzyme lipoxygenase. Let's see the acid hydrolysis of compound 16 and 17. A solution of compound 16 and 17, each taken 8 mg in methanol, that is 5 ml, containing 1 normal hydrochloric acid, that is 4 ml, was refluxed for 4 hours. It is concentrated under reduced pressure and diluted with 8 ml water. It was extracted with ethyl acetate. The aqueous phase in each case was concentrated to obtain the glycone part, while the organic phase was provided the corresponding aglycone part. In all the cases, the glycone part could be identified as D-glucose by the sign of its optical rotation, that is alpha D 20 plus minus 51 for compound 16 and alpha D 20 plus minus 51.3 for compound 17 respectively. It was also confirmed by its retention time, and it goes with the standard. The time for alpha anomer is 4.1 minutes and the time for beta anomer is 7.8 minutes respectively with the standard. The assignments for this class session is: what is the importance of proton NMR spectroscopy in the structural elucidations of the organic compounds? Explain its applications. Second, discuss the applications of monoterpene glycosides. And third, discuss the natural sources, uses and pharmaceutical products of centrolinol. Thank you so much.